Hello everyone. Here we'll just see how to deal with the SolidWorks motion studies, and here my requirement is how to capture the force required to just displace this particular component with respect to the spring which I'm going to attach here. If the displacement is 20 mm or 30 mm, to displace this much with respect to this spring, how much force is needed to move this lever, that I need to find out. To deal with this, I'll create a new study to just understand the better concept here. I'll create a new motion study. I'll start from the scratch. The first thing is I'll apply the gravity towards downwards. Okay, from the animation to motion analysis, I'll change in the add-ins. The motion manager is active. Okay, not an issue. And now next thing is contacts. If you want, you can assign, otherwise not needed. So better to go with the group contacts as well if you need it. Okay, assign the contacts like this. Okay, once you assign the contacts, you can go ahead with the spring definition. You can choose the point or the face to select the face. So this is the spring. I'll add the value 6 Newton per mm. That is spring constant. Remaining everything is same. I don't want to change anything here. Green check. The spring, virtual spring has been applied. Next thing is to apply the motor. Here for me I need the 20 to 30 mm displacement, so I'm going to define it. So let me just select the face or a point. I suggest you to go with the face or a point. Anything is okay. Here I'll select the distance 25. Okay, 25 mm I need to displace towards up. So this is the mechanism which I'm looking for. So I'll just simply calculate this much. Okay, this is the mechanism now. Now to just plot the graphs accordingly, you can go ahead with the results. Then from there I need the force, that should be motor force, magnitude with respect to the motor which I have applied. That you can choose it from here. The motor. Click on green check. So according to that, the motor force will be generated. That is 25,740. So which is quite high because of the spring. So what I can do is I'll reduce the displacement from 25 to 18. Okay, and let me just cross check the same again. So I go back here. Yeah, this is 102, so which is fine for me. Now according to this, I need a 102 Newton force to move this one up to a certain distance. So this is one way. Otherwise you can do apply the motor, that is rotational motor. According to that also you can find out. I'll showcase how to do that. I'll just create a new study accordingly again. So everything is same, no much changes there. Gravity downwards, and then contact if you want you can assign, otherwise you can leave it blank. I'll change it to motion, and the spring is default. Okay, so here the spring constant is 6. Now instead of a linear actuator, I'll go with the rotational motor. So I'll select, I'll reverse the direction. So here I'll just define the distance with respect to degrees. I'll define 10 degree moment of this. So with respect to that, how much the displacement or whatever the force required to find out this much, you can calculate it. Okay, this is fine. If you want, you can even reduce the value to 5 degrees, so I can recalculate the same. Okay, and then you can go to the plots, force, read the motor torque, magnitude, and this is the motor, and according to that you're gonna get the results. Okay, the torque required to move this is 5196. Okay, and according to this particular motor, the results, one more thing is displacement, how much it is. I need to find out. If you want to find out, and go ahead with the linear displacement, magnitude, here I need to select the mate, so you can use the drop down. From here you can choose the mate. This is the mate, and this shows the 10 mm displacement. Okay, so this is how we can able to deal with. So to move this particular means I applied the rotation of 10 degrees. With respect to that, the linear moment is 10 mm here, and the torque required we got over there. This is how we can deal with. So with respect to that, you can find out the force required and all. So just to conclude, you can even select that. I think motor force. Okay, if you have the motor, anyway you're gonna define the same, you won't get it. Okay. Fine. There might be some questions which previously asked by the people. If I have the any of the alternative connector here, if you apply the same mechanisms and all, will it interfere? So practically it is not, because if I add the wall here, if I define the same mechanism, if this particular face touches this wall which is added here, it will automatically cross that wall, because practically that should be the case, it should stop. But here the software just take the input what you're giving with respect to analysis, and according to that it will produce a mechanism. Okay, it won't take this particular contacts into account to deal with these things. So whatever the input springs and the loading conditions and the motor you apply, according to that the mechanism, it just algorithm in the background, it will calculate it, it will give the results. Okay, so practically also that is not possible. To avoid it, you already know, we can define the advanced mates limit limit distance. So if you have any of the components, you can define the limit mate up to from here to here, it should not cross like that, to avoid that kind of steps. And anyway, in practical that is not at all possible, interference and all. Anyway, we can avoid them. And one more thing, key reaction force. So usually everyone thinks key, if I want to move this one to up to 20 mm, how much force I need to apply on this face. So I do need to find out the reaction force on it. To find out the reaction force, there should be connections, right? Means the component should connect, or there should be any some connections, sort of connections, to find out the reaction forces. So that is not applicable here. So if you want to find out the reaction forces, you need the connections or the mates references. So for that, you can go ahead with this plots, forces, reaction force, magnitude. So from the mates, you can choose the mate where these two contacts. This distance mates, actually I don't want this. Yeah, this is fine. On this contact I want to find out the reaction force, and it gives the same. The reaction force on that particular component is 71 Newton. Okay, so this is how you need to deal with the motion studies, finding out the motor torque and the displacement and all. I hope this video might help you to just recall everything and to solve your case studies. Thank you. Stay tuned.